Welcome to the channel! Today, we're diving into one of the most exciting and dynamic fields in artificial intelligence, reinforcement learning. Whether you've heard of AI mastering video games, driving robots, or optimizing complex systems, there's a good chance reinforcement learning is behind it. By the end of this video, you'll have a clear understanding of the key concepts that make it all work: agents, actions, and rewards, plus powerful algorithms like Q-learning and policy gradients. Let's get started. What is reinforcement learning? So what exactly is reinforcement learning? In simple terms, it's a type of machine learning where an agent learns how to behave in an environment by performing certain actions and observing the results of those actions. The goal? Maximize rewards over time. Think of it as training a dog to sit. You reward it when it does the right thing, and over time, it learns to repeat the behavior that earns treats. A diagram of an agent, environment, and the cycle of actions and rewards. In more technical terms, reinforcement learning is about decision-making. An agent explores an environment, takes actions, receives feedback in the form of rewards, and adjusts its strategy to improve future outcomes. The beauty of reinforcement learning is that the agent is never explicitly told which action is best. It has to figure it out through trial and error. Key concepts: agents, actions, rewards. Let's break down the essential components of reinforcement learning. Agent in an environment with arrows showing actions and rewards. The agent is the learner, or decision maker. It's the part of the system that is trying to learn the best way to accomplish a task. The environment is everything the agent interacts with. It could be a video game, a robotic arm, or even the stock market. Actions are the moves the agent can make. For example, in a game, the actions could be moving left, right, or jumping. In robotics, actions could be turning a wheel or moving an arm. The reward is the feedback the agent gets. A positive reward encourages the agent to repeat the action, while a negative one discourages it. The agent's goal is to maximize the total reward over time. How reinforcement learning works. Now that we know the basics, let's dive into how reinforcement learning works step by step. First, the agent observes the environment. This could be as simple as knowing its current location in a maze. Based on what it observes, the agent selects an action. Early on, it might just guess randomly, but over time, it learns which actions work best. After taking an action, the agent receives feedback in the form of a reward or punishment. This helps it understand if the decision was good or bad. The agent updates its strategy. Over time, it learns to prioritize actions that lead to better outcomes. Q-learning and policy gradients. Let's move on to the algorithms that make reinforcement learning so powerful. Two of the most widely used are Q-learning and policy gradients. Cut to a simplified diagram of Q-learning. Q-learning is one of the most famous algorithms in reinforcement learning. It helps an agent learn the value of taking a particular action in a given situation. The Q stands for quality. Essentially, it tries to answer the question: if I take this action in this state, how good will it be? Over time, the agent builds up a Q table, which tells it the best action to take in every possible situation. Q table example with states and actions. Policy gradient methods, on the other hand, focus directly on optimizing the agent's policy, the set of actions the agent chooses from, rather than building a table of values like in Q-learning. These are often used in more complex environments, especially when the action space is too large for a Q table. Policy gradients are more flexible and powerful for tasks like playing video games or controlling robots in real time. Real-world applications. Reinforcement learning isn't just theory. It's making waves in the real world too. Perhaps the most famous example of reinforcement learning in action is gaming. AI agents trained with reinforcement learning have mastered complex games like chess, Go, and even video games like Dota 2 and StarCraft 2. In fact, Google's DeepMind developed AlphaGo, which defeated the world's top Go player, all thanks to reinforcement learning. AlphaGo match. In robotics, reinforcement learning is used to teach robots how to move, manipulate objects, and even interact with humans. Imagine a robot that learns to walk or balance just by trial and error. It's incredible. Footage of a robot walking reinforcement learning also plays a crucial role in self-driving cars, where vehicles learn to navigate roads and make decisions in real time. Footage of a self-driving car. To sum up, reinforcement learning is a powerful tool that enables machines to learn by doing. From games to robotics, its applications are vast and its potential is enormous. If you enjoyed this video, make sure to like, subscribe, and hit the notification bell to stay updated with more awesome AI content. And if you have any questions or topics you want us to cover, drop a comment below. Thanks for watching.